Hey everybody, it's First Warden Storm Team Chief Meteorologist Brad Panovich. I'm outside today because we're talking about a topic that I love because I love weather stations. We have done some segments in weather school about certain instruments and stuff, but today I wanted to focus on weather stations in particular because I have several in my house, probably way too many. But I want to explain some of the things that go into weather stations, what makes weather stations great, what makes them accurate. If you're looking for an at-home weather station, I'll give you some tips and some things you can look for. But I want to start today with talking about weather stations. So I'm outside and I'm going to take you a little tour of my backyard. I actually got a part of a weather station back behind me, and I'll explain, and one up on the roof that I'm going to show you in a minute. But let me go to our full screen here, and I'm going to bring up our first weather station here because this is a one of the first weather stations that we had at the station. We actually mounted this on our storm tracker. The thing I love about this is that it's all inclusive. So inside this weather station, we have an anemometer, we have a wind vane or weather vane, and then embedded in here underneath these upside down looking plate things, these are actually the thermometer, hygrometer, and barometer, and I'll explain what those are in a minute. But first, one of the most important tools in a weather station is the anemometer. Anemometer, it's a mouthful. The best way I can describe this to you is this is a speedometer for the wind. This is a type of anemometer called a cup anemometer. Other type of anemometers, I'm going to show you a really cool one that I have an experimental one, two at my house that are ultrasonic. They're really cool. I'll explain more about that. A basic anemometer is a wind sock. It's just a sock that blows in the wind, and it basically the more it blows out, the higher the wind is. The wind sock, you'll see that at airports or helipads. Below this is a wind vane or weather vane. Okay, now a wind vane or weather vane, it's technically a wind vane because it tells us which direction the wind is going. Now it looks like an arrow, so everybody thinks the wind is going that way. But here's the thing: it points into the wind, so the wind is actually coming from this direction. What happens is this airplane tail looking wing thing, if the wind is coming from this side of the screen, it blows that wing around, it blows over here, it swings around, the wind hits it there, and it basically bounces back and forth until it points directly in the wind. So the wind is actually going this direction. So it looks weird, the arrow's going the other way, but it points into the wind. Now, why is it called a weather vane sometimes? Well, if you watched our previous weather schools, we talked about the importance of high and low pressure. If you know if high or low pressure is moving in, you can predict the weather pretty accurately within 24 hours using a barometer. But because high pressure spins clockwise and low pressure spins counterclockwise, you can also tell if the high or low pressure moving in based on the wind direction. So farmers learned this right away, that if we had a south wind, we had low pressure heading our way. If we had a northwest wind, high pressure was moving in. So you can kind of tell the type of systems moving in, whether good, bad, or indifferent weather. And so farmers would call them weather vanes, and a lot of people call them weather vanes because they help you predict the weather. That's why most of these are on barns. You might see them as a rooster up on the roof. Then inside this part is the thermometer, which everyone knows measures the air temperature, and the hygrometer. Hygrometer is a fancy word to measure the amount of moisture in the air. There's humidity outside, dew points, molecules of moisture in the air right now, so spread out that you can't see them until you squish them together. So the hygrometer measures the amount of moisture or water vapor in the atmosphere. There's also a barometer in here, which tells us the atmospheric pressure. Now, this is the key part, and part of the reason I'm outside is there's these upside down looking plates. Why are those there? This is the most important part of a weather station, and where a lot of people get bad temperature measurements. The temperature and actually the dew point should be taken in complete darkness, not the shade, complete darkness. These are called radiation shields. Radiation shields sound really scary. Right away, people think, oh my gosh, radiation? What type of radiation? Well, I'm not talking about nuclear power plant radiation. We're talking about radiation from the sun, ultraviolet radiation, the biggest source of radiation on our planet. We do not want to contaminate the temperature with sunlight. We're not measuring the temperature of the sun. We're measuring the temperature of the air. So we only want the air to be sensed or measured. So if sunlight is getting in there, hitting the sensor, we're actually measuring the incoming solar radiation heating up the sensor and not heating the air. And if it's open to the ground and there's a light bouncing off the ground, we're measuring that as well. So even in the shade, even though you're not in direct sunlight, you're getting indirect sunlight, you would not get a correct measurement. So a lot of people buy weather stations or thermometers and put them up at their house and wonder why they read so sometimes too warm or too cold. It's because they're not shielded correctly. Because at night, the opposite happens. When there's no sun, the more view of the sky you have, things cool off quicker than they should. You're actually called radiational cooling. This is how we get frost on mornings where the temperature is not below freezing, because the surface can cool to the freezing point even though the air can stay above the freezing point. And I'm going to put this down. I'm going to walk over here to my weather station because I want to show you a big version of this. This is actually my weather station at home over here, and I have it mounted back here. It's wireless, but you can see well, there's a bug on there. You can see an example of a pretty significant radiation shield. So there's the thermometer in there. There's also a lightning detector, and there's also a hygrometer. So these upside down plates, there's several of them, keeps this from being affected by sunlight. Now, I have this over wood chips, which isn't ideal, about 4 feet off the ground. That's important because above a grassy surface, which gives us a pretty accurate measurement of the air temperature. So let me show you some rain gauges, because attached with that weather station is a rain gauge as well. You probably have never seen a rain gauge like this. It doesn't look like much. The rain goes in there. I have a broken one, which is great. This is what it looks like when it's been outside for a long time. This is all this is. This rain gauge has a funnel that sits on the top. This is called a tipping bucket. The funnel rains, it fills up that bucket. That bucket holds exactly 0. It counts the number of tips, and we do the simplest math I'll do all day. You add up 0.04 plus 0.04, we would have 0. A tipping bucket, because that's not the lowest measurement of rainfall. In fact, it was doing that. We have a drizzly, misty day, it might just do that, so it doesn't measure nearly as much. The other type of rain gauge, a little less accurate, this giant thing. So it's got a float, which will float up in there and tell us the measurement. Now, you can see accurate measurements. The most accurate measurement of rain is actually using this manual rain gauge we call a Kokoruz gauge. It's got a tube in there with the measurements to the nearest 1/100th of an inch. Notice those little marks? That's the lowest measurement of rain, 1/100th of an inch. Anything lower than that is considered a trace. And just for reference, snowfall, the lowest measurement is 1/10 of an inch. So a trace is actually less than 1/10. So trace of snow is snow. That's the ratio. So how this works is this sits inside this giant tube, and you can see it goes up to 1 inch. And you're like, that's not a lot of rain. What if we get more than that? This is where this part comes in. This sits inside here. We will actually get rain to fill up that middle tube. If it fills up 1 inch, it'll overflow into the external part, which holds an additional 5 inches. So this whole gauge can hold up to 6 inches of rain. So you have to go out and check this every day. When we go outside, what I do is if it's overflowing, it'll overflow inside here. I take this and I say 1 inch of rain, I dump it out. Whatever water's left in here, I'll dump it in here. And if it fills up again, it'll be filled up, and I will dump it out again. And then I'll take that moisture and put it back in here. It'll fill up again. That's 3 inches of rain. So we can add up to 6 inches of rain within the rain gauge we have out here. And actually, I have one over here. I have 2 of these Kokoruz rain gauge. These things are about $20 to $30, depending where you are. If you want to become a spotter, this is the best thing you can do in your yard, because rain is the most variable form of weather we have. Temperature does change a little bit from neighborhood to neighborhood. It changes over bigger areas, but rainfall is dramatic. It literally can rain in your neighborhood and not the next. So rain gauges are really important. And if you want to measure rain, you need this one. This is the standard official rain gauge. We love these rain gauges. Everybody should have one of these, in my opinion, to measure rainfall. Now, I talked about a really cool weather station that I'm actually have at the house that I'm working on right now. I'm testing, and it's really cool. This is it. Okay. The cool thing about this weather station, every part of the weather station is in this one piece. I don't have separate pieces. They're all right here. And you can see this side actually has solar panels. So this is powered by the sun. It's wireless. You can actually see it's got radiation shields here. So you know it's got the thermometer, hygrometer in here. But here's the cool thing. You're probably asking, Brad, where's the anemometer? Where's the rain gauge? Where's the wind vane? All that stuff. This is it right here. This thing is 2 plates. You see the 4 holes there? These 2 plates have sound waves that bounce back and forth. So as the wind goes through these plates, it disrupts the sound waves and it measures the wind speed. It's the most sensitive, accurate measurement of wind speed because there's no moving parts. So it can measure just the subtle little bit of wind. It's called an ultrasonic anemometer. So it basically measures the wind going through these plates. And because it knows what direction it's coming from, this is due north, that line right there, we know what direction it's coming. So the cool thing about not having any, so why is it important not to have moving parts? Well, first of all, a little bit about physics. With anything that moves, if we're measuring the wind speed, it's going to take some initial energy to get this moving. So the first maybe 1.5 mile per hour of wind actually is used up making it move. So it takes enough wind to get this to move. So low end wind speeds, you have a tough time measuring because it takes enough wind to get this going. So if this takes 1 mile per hour to move, that means anything less than a mile per hour we would never measure. The other thing is anything that moves breaks eventually. It just wears down. The other thing, during ice storms, ice is up. So anything that moves breaks. The nice thing about having no moving parts with an ultrasonic anemometer, nothing breaks, nothing freezes up, and you get lower measurements. Now, the other cool thing about this, where's the rain gauge, you're asking? This is probably the coolest piece of technology on this. This plate on the top is a pressure plate. It's called a haptic rain gauge. And what that means is it actually senses raindrops hitting the top. And whether they're big or small, this runs an algorithm, basically a calculus equation, and it figures out how much rain is falling and how fast based on the number of droplets. And the nice thing about it, it's self-learning. It's got AI, so it'll learn over time based on real-time weather stations in the area that if it's over or underestimating. And I've been honest because I've had this one in my yard and this one on my roof for about a year now. This is within about 10% accuracy of this, which is saying something because I don't have to check it. I don't have to clean it. I don't have to go measure anything. It does it all on its own. Also a cool feature, that's actually a UV sensor, so it lets me know how much UV light is coming in. And then inside there, obviously, we have the thermometer, hygrometer, barometer, and a lightning detector. So this measures a lot of parameters all in this small little package, which you can mount on a 1-inch pole and stick up on your roof. I love this weather station, and I've been testing it for a while, and I have one of the previous models, and I think to me this is going to be the one I would recommend for everybody. It's not cheap though. It's going to be about $300, and that leads me to my next thing. If you want to get a weather station for your house, they range from as little as $30 to $50 to as much as $1,000. And so what are you paying for with an expensive weather station is, one, it does a lot of cool things and it measures a lot of cool things. But here's the most important thing. Pretty much every weather station is going to work fine initially. The cheap ones just don't last. What you're paying for in price is duration, how long they last. Remember, this is going to be in the weather every minute, every hour, every day, 24 hours a day, 7 days a week, 52 weeks a year for years and years and years. Just like this one, you know, this is what it looked like a couple years in the sun. These things will wear down. That's why no moving parts and one piece, and the price you're paying for is this thing to last forever. Also, I like about this, solar power, don't have to worry about changing batteries. The other thing is I don't need a computer on. This will measure it continuously. I have a hub inside my house, and everything is sent to a smartphone app. So you can bring this up on your phone. And so the one on my roof right now, that's the temperature up there. And you can see I actually have a lot of parameters, wind speed, voltage. UV index right now is very low because it's cloudy. But it's a very cool weather station. And when I'm done testing it, I'm going to do a big review and, you know, let people know what I think and why I would buy this. So, you know, why is it important to have weather stations? Well, obviously we have weather stations at all the airports and all over the world and country, but the more we add, the more data that goes into our numerical modeling. The only way we can forecast the weather is by knowing what's happening now all across the world at the same time, and then we can forecast or simulate what the atmosphere is going to do into the future. So weather stations are cool. Before I go, I want to show you the ones I have up on my roof. I'm actually going to see if I can show this. So that's the one up on my roof right in the middle of your screen. I actually have two of them mounted up there right now with two cameras to kind of show you, and just to show you that I am full into this. I've got two weather stations at my house. One unit completely up there, and obviously the temperature gauge in the backyard. So that's today's weather school, all about weather stations. So if you're interested in weather stations, feel free to ask me a question. Shoot me an email if you're looking at a certain station for your backyard. I get that question often, and I will tell you just get one first. Start small. Maybe as you get into weather stations and backyard weather spotting and observing for us, you can work your way up to something like this, because this is the Weather Flow Smart Weather Station. I think this is the wave of the future. Anyone can install this. You only need a smartphone app. You don't need a computer. You just need Wi-Fi, and that's it. And you're good to go. And this data can be made public or not public, depending on what you want to do with it. You can look at it at your phone. Your neighbors can look at it. You can make it anonymous. Really cool. And this data, if you feed it publicly, will go into the weather models and hopefully improve the forecast for your backyard. Hope you're having a great Tuesday. I'm heading into work today. We're tracking some severe weather tonight. We'll be on at 4, 5, and 6. And as always, if you missed today's or you missed any of the previous weather schools, you can go back to our WCNC YouTube channel and you can watch them there. Hope you have a great day, and we'll see you tomorrow at 1 o'clock.